Hi everyone, welcome. Okay, so let's get started. We are 3 weeks on break and coming back directly into the jits, which is going to be a lot of fun since it's not the simplest part of the codebase. And what we're going to do is we're going to do a quick review of the actual problem that we're solving before we jump into how we solved it and how we're going to move forward from there, and what we didn't do last time, what was missing, because we were missing a really important piece, which I skipped because I wanted to show the full progression from the interpreter to the Ion compiler before showing how the optimization parts actually worked. Okay. So there's a couple of more questions that I'll just quickly answer. Right, so using HackerRank to test your experience in problem solving, that's definitely something you can do. There's a lot of ways you can do that though. So HackerRank isn't the only place to challenge your mind to see what kind of problems you can solve. Another question is, are we hiring for the compiler team at Mozilla? I'm not the best person to ask, but Mike Conley just posted our careers listing page. I think at present it's a little bit unlikely to, just given the current state of the world, I don't know if we're hiring right now. But check that page and check back and then see what's there. And you might find an appropriate job listing there. Okay, good. So let's review where we were and a quick introduction for people who have never been to this stream before. Oh, I didn't size that right. This is a stream about hacking on SpiderMonkey. And what we do here is we solve small bugs to help. We solve small bugs to help us understand how the compiler works. And what we're doing is we're starting from something called a test 262 test. Test 262 is the test suite which ensures our conformance with the specification, which is ECMA 262. You might know it as ECMAScript, or most likely you know it as JavaScript. So what we do at compiler is we solve problems in order to get a better understanding of how the specification works and of how one implementation works. There are other implementations other than SpiderMonkey. I mentioned V8, which Maria Hulta is working on, along with a number of her other colleagues on V8. And if you read the notes from TC39, also her colleague Shu is working on it, and a number of other people. As well, there is another engine called JavaScript Core that is the Safari engine, and it's part of WebKit. There are additional engines. That's not the only engines that exist in this space. So you probably know that Node is actually also V8, but there is another engine called Moddable, or XS, which is a JavaScript engine specialized on implementing JavaScript for microcontrollers. So those are that's kind of like a really rough landscape. There's also a really nice interpreter called ECMA Engine 262. Engine 262 is written by Devsnek, who also sometimes comes to these streams, and they did a really fantastic job in doing a step-by-step implementation of the ECMA 262 specification in JavaScript. So some people are asking if I can post some stuff. Let's do that in the second round. So like once I finish showing what we're doing today, we can have an open chat and I can share with you different places you can look for more information. And I can share with you other questions that you might have. And yes, I just noticed that someone posted about Igalia. Igalia is a really great place to look. They specialize on standards, open standards in the web. They work on V8, JavaScript Core. They work on SpiderMonkey as well. So that's another place to look if you're looking for compiler jobs. All right, so I have my pen. Let's get started. Okay, can I do anything here? Apparently not. 1 second, everything is broken. Okay. Oh, this is fascinating. Okay. I had a lot of trouble getting my drawings set up today for some reason. I'm not sure why, but it was a real pain. So I may be struggling with that a little bit today. Can I draw? Yes. Can I undo? Yes. Okay, cool. So what we were doing at the very beginning of all of this, like before we started any of this, is we were looking at this use case. We had a base of some sort and a key. Now, if base, let's see if I can write more cleanly. Base, can never write very well whenever I'm streaming, but when I'm doing it by myself, it's fine. Base equals null or undefined, so what I have here. And the key throws. So what happened in the SpiderMonkey implementation is if we had this, if we had a decrement or, sorry, not a decrement, a postfix increment notation or a prefix increment notation, and this is the prefix. So this is prefix. Here I am trying to write prefix incrementation. So at my very first stream, someone was asking what's the difference between prefix and postfix notation. Not being a C++ developer and never having used the postfix one, I was like, I have no idea. There is a difference. Prefix is, oh gee, now I forget. Prefix is you get the return value is the original value and then you increment it. And postfix, I think, is you increment it and then get the return value. I can never remember, but something like this. So the main thing here is that we've just got this change in the character, change in the text that shouldn't have the impact that it does in SpiderMonkey. So adding this prefix shouldn't change how we interpret this part of the expression. But in the SpiderMonkey engine, the interpretation was changed. So for example, if you did it without having that prefix notation and the key here through a dummy error, what you would end up with is the dummy error being printed out to you in the console. So that was the correct behavior. We verified it in the specification. It is indeed the correct behavior that we throw the dummy error first, rather than saying that base is undefined. But the behavior we had in SpiderMonkey was we would get a type error that base is undefined. So we would check this if it's undefined first, and then we would go on to this key and do whatever the key was saying. Does that make sense to everyone? Are we all on the same page? I can also pull up the spec if we want to take another look at the specification. Someone's asking me if I have a background in PL. I don't have an academic background in programming languages or in computer science. We want to take a look at the spec, so let's do that. I have too many keyboards. Uh-oh. There we go. Specification. So you should be able to see the specification now. Okay, let's take a look at the spec. Why was the behavior that SpiderMonkey had incorrect? Let's find out. And what I'll do is I'll go to property access, and I'm already where I want to be. So, darn. How can I do this without breaking everything? Okay. Here is my iPad, and this is a part of grammar. And what happens is when you have grammar, it has little connection points, and you can plug in different pieces into it. And then you end up with a little chain of expressions that can eventually even loop back and be recursive. So what we're looking at here, like when we are evaluating an expression, what we do is we go through the grammar and parse according to how the grammar is defined. So if we go to the very top level And let's say, what was it? I think it's a prefix increment. So here we are with the prefix increment operator. And the runtime semantics tells us a little bit about it. I think we can also find, here's assignment target type. That's what we're doing. So a prefix operator is an assignment target type, which is which takes the form of an update expression. And an update expression, it can be either a left-hand side expression with the postfix operator, a left-hand side expression with a postfix decrement, a prefix increment unary expression, or a prefix decrement unary expression. And we'll take a look at, let's see how that all falls through. And all of these are linked inside of the specification. So the specific thing that we're looking at is the unary expression. And actually, before I start skipping through this, you can read this all in the specification. So here we have runtime semantics evaluation. So we have the unary expression, and we say let x. We're assigning a variable here. You can really read the specification almost like code, just in prose. So here we're saying let expression be the result of evaluating unary expression, and here we have unary expression. So if we dig down, if we want to drill down through all of these definitions, we can click on it and it'll take us directly to unary expression. So what could a unary expression be? Well, the other thing about grammars is that they go from, they have a precedence from the topmost definition going downwards. So we'll start off we'll start off with a question like maybe update expression is the thing that we need. So we click on that, and then I got confused. Unary expression, and then it goes to, how did I do this last time? I forget. A unary expression is an update expression, which can also be a left-hand side expression. I missed the very first one, so this is the one. Left-hand side expression can be a new expression can be a member expression can be a member expression with this open bracket expression close bracket. Sorry, that was a little bit confusing. I missed one of the lines. Are people following me so far? Just give me a yes or like a thumbs up or something. We've got some yeses. Fantastic. Please stop me if you're confused. Okay, cool. So we're looking at this grammar right here. Now, how do we understand that grammar? Like, what do we do when we see something like this? What we can do is just like read through the semantics. So syntax is what does this thing look like, and semantics is what does this thing do. I somehow got totally lost. Okay, focusing. We had a member expression. So we're here. And we want to go to the assignment target because this is going to be an assignment target type. I'm skipping a couple of steps because I wasn't expecting to do this part, but if it's confusing, please let me know. So this is the part that we're interested in. We're assigning, because the plus is assigning a value to the thing that we're working with. And then here, what we can do is find it, just find exactly what we're looking for. Here we are. Runtime semantics evaluation, we have the member expression is a member expression followed by a square open bracket, followed by an expression, followed by a closed square open bracket. Okay, good. Then we say, let base reference be the result of evaluating member expression. So we're talking about this part. Now, if we are in the world of SpiderMonkey, the example that I showed you, where base reference is undefined, then this value here, let base reference, will be undefined. Oh, sorry, other way around. This base reference will be the pointer of, I believe it was called base in what I showed you earlier. It'll be a pointer, and then we say let base value, get value is the thing that actually gets the value out of the reference, so base value is the thing that's undefined. Sorry for the confusion. If the code matched by this member expression is in strict mode, let strict be true. So this bit is irrelevant for us. And then we're going to evaluate property access with expression key with this interesting little question mark. I won't go into that, but go and read Maria's blog posts, and she does go into it, which is fantastic. Okay, so now we're going into, you can think of it as a function inside of the specification. And here it says, let property name reference be the result of evaluating expression. So let's go back and let's take a look at what the values are. So base value, I've mentioned to you before, is undefined because our base object that we were working with is undefined. And we pass that in as an argument, followed by the expression just as it is here. And then we pass the strict thing, but we're not going to pay attention to that. We're skipping a few details. Okay, cool. So here we say get the reference of that expression. So if it's a variable name like key, we need to find out what the thing is that it's going to be pointing to. So like the pointer. And then we say let property name value be get value. And now we extract the value from wherever that address is. And now we've got this thing called property name value. So here's where we where things go a little bit funny, because when we're getting this value, what this is doing is it should get us the actual value that's inside of that, let's call it a pointer, that's inside of that reference. Let's call it a reference, that's easier. We're extracting the value from that. So we should already have the error that the function is throwing, that the key is throwing. So we've got a key that throws an error, and we should already have that value there. But what SpiderMonkey does instead is it takes this step and it does it a couple of steps above. So it does it before this one step. Does that make sense? And I can show the bytecode for this. That might actually make it easier to look at. So effectively, the problem that we had, and I did draw this out, is that theoretically I have it here. So we had in the bytecode check object coercible before we emitted the value from the expression that's inside of the brackets, which is wrong according to the specification. So in order to fix it, we needed to rearrange our bytecode. I think the best way to show this is to actually show it. So I'll show you an example in the old code base and then what we fixed. So I should be able to just run it here. And let's say that we just have some value like O equals null. This is the use case that we're dealing with. And then we have a key that equals a function, throw new. I think that'll work. No. I need to put these around it. Okay, so key should throw. Perfect. And let's take a look at what happens when I try to access the key on this null object. This is right. Sorry, it took me a second. I was like, why is this right? This is right because this is exactly the inconsistency that we're trying to fix. Because if I add this, you'll notice that this error message is wrong because we evaluated what O was. We checked O for being an object before we checked key, whereas in this original version, we checked key before we checked O. Okay, are we all on the same page? Everybody with me, I hope. I'll also show what it looks like if we disassemble this piece of code. So this is the disassembly of that code, which is not doing the coercion that I expected. I think if I remember correctly, it gets fixed. 1 second, let me see if... Ah, yeah, I remember. It's because our we don't have to check if the object is coercible for the regular assignment, or I think it gets optimized out. It's not terribly important for what we're doing today, but here you can see the bytecode where we are doing the coercion, so you can see what the problem is. We check object coercible on X before we get Y. So this is getting the Y reference, and then we're calling it and getting the value from there, and then we're transforming it into a property key, yada, yada, yada. Okay, cool. So, are the rest of my slides even useful? I'm not sure. Let me take a look. Yeah, okay, so I'll do a really quick summary about what the problem was. So the problem with just putting check object coercible, so our initial solution to this was we rearranged the bytecode. And the thought is like, oh, you can just move check object coercible and it should be fine. But the problem with just moving check object coercible is that check object coercible looks at the top element of the stack, which in the past was base. And it's no longer the case, because what we did is here we pushed a key. Well, actually it's not even a key, it's some value. And now key is at the top. So what we have to do is another operation, which is called swap, and then we get the base and can properly do check object coercible. Okay, fantastic. But that's not actually all that we have to do. There's a second step to all of this, which is that the same is true of toProperty key. So toProperty key should actually be looking at the thing that needs to be transformed into a key. And if it's looking at this base, it's trying to transform the wrong thing into a key. So we again have to swap, and then we do toProperty key on the correct value on the stack. And this is again because we're rearranging the stack. This is like slightly less than ideal. Because what we have is sort of a situation on an important piece of code. So accessing an object through getElem, setElem sort of stuff is performance sensitive. So this, like just moving the bytecode, which would have been an ideal situation, doesn't work because of how the stack is built and like basically what our implementation is. It doesn't work because of our implementation. This works, but it means that we need to add 3 bytecodes, which isn't great. And I think it was in the second episode I implemented this and we tested it, and it turns out that it's not too much slower, but the problem is that also our error messages become less useful. So the final thing that we do is we implement a new bytecode. And that's the basis of everything that we've done for like the last month and a half or so, is how do we implement a new bytecode and how do we optimize it? And the question of how do we optimize it is what we're going to answer in this episode. Okay, whew. Any questions so far? Have I lost anybody with my totally running all over the place talking? I don't know if I've lost anybody. Looks like I haven't. Oh, a whole bunch of people said stuff. You're with me, everybody's with me, great. And we should have a flag to do better stack trace formatting. Was it bad? I thought it was good. Yeah. And it all makes sense and everybody's with me. Okay, fantastic. Okay, let's actually do some programming then. I do have some more slides that I couldn't get into my, ooh, and I actually even closed it for some reason. Okay, I have more slides. They're actually in the little booklet that I shared in Twitter that I couldn't, for some reason, the program's refusing to let me add more stuff to the drawing board. So if it's necessary, I'll pull it up and then we'll go through it again and stuff like that. So I'm having a bit of a technical issues day. Okay, getting this all set up and not panicking. Okay. Emptiness. Actually, maybe let's see where we're at. Or, yeah, I've got a Vim already. So let's go to, let's go to the build directory and let's test the version that we currently have, which should do the right thing. So if I say O equals null, and then I do the same thing that I did before. And then we increment because it only happens in this case. Excellent, great. So this is the fixed version. It's not entirely fixed, but it's fixed to the point that we have it implemented in the interpreter. We have something implemented in the baseline jits, and we have something implemented in the ion jit. And if you want to catch up on those episodes, you should definitely check those out. What we're going to do in this episode, and maybe I should actually just get that thing up. What we're going to do in this episode is we're going to take a look at how do we make this fast? Hopefully you can see that now. I'm really sorry about all the technical difficulties. I wasn't expecting it to be this bad. So the question is, how do we make this fast? And what we're trying to make fast is the property access. So I've made most of these slides around property access. A good question about why aren't we fast is to ask what's making us slow. And the thing that's making us slow is we have to check when we're looking at this something thing, where we're doing F and then something is being accessed. We need to check if it's a string, if it's a number, if it's this other thing, if it's something else, etc. And this isn't very fast. To make things faster, we can cut all of those branches and be like, we know this is a string, so do the thing that you need to do when it's a string. Or we know this is a number, do the thing that you need to do when it's a number. And another thing that I wanted to talk about very briefly is like, what is a script? Because this relates to how things are optimized and then de-optimized. Because sometimes you want to optimize things, sometimes you want to de-optimize them. So what do we have as a script? What is this unit called a script? Well, a module is a script, which probably isn't surprising. A script is a script, also shouldn't be surprising. Eval calls are treated as scripts, which might be surprising, and functions are also treated as scripts, which might be particularly surprising depending on how much experience you have with JavaScript backends. Additionally, you might ask, like, how are these things being represented? And they're represented in phases. We have this data structure called a JS script, or a script, which we use throughout the backend, throughout the VM. And that adds data as we learn more about the thing that we're working on. To start with, we pretty much always have a base script, and that contains the metadata. And it also tells us, like, do we have bytecode or not? Because not all scripts are going to have bytecode. We can do something where we only parse the syntax and then we throw everything else away. For example, if you've got a really big script and there's a function and it's not being run, like, we don't want to compile, and we don't want to interpret that or be able to interpret that until we actually need to. So not everything has bytecode. When it does have bytecode, we add it to the runtime script data, and then it contains bytecode. So that's when we can interpret stuff and understand things. Then, and that's what we did in, I think it was the 3rd episode of this series. Then we get into the stuff that happens with the jits. That's the JIT script, the baseline script, and the ion script. And fundamentally speaking, JIT script is the thing that does inline caches, which this episode is going to be all about. Baseline script contains native code, and Ion script contains optimized native code. And inline caches are the thing that helps us output that native code. There's some detail to this that I won't be able to go into, but possibly some of the commenters might be able to clear up any questions you have. So another thing to pay attention to is that we are sharing pieces of information across all of these layers. So bytecode is something that's useful across all of the layers. We might look into it. We might be in a baseline script and be like, what's the bytecode for this? Or an Ion script. Actually, I think in Ion, I'm not sure if we actually use the bytecode very much, but I think we use it a little bit. And then inline caches can be used to help generate those two things. Ion scripts also have a little bit of, so the Ion compiler has some superpowers where it can do stuff like look at baseline and stuff like that. So again, we're looking at a simplified window of what's happening. Yeah, and additionally, so baseline script, you can think of that like it's a data structure that contains the actual information, that contains the actual native code. And same thing with Ion script. If you ever want to play around with this, put a breakpoint into debugger, break something and see what's happening, those might be really cool places to look. Okay, so we're focusing completely on JIT script because that's where the inline caches happen. And in order to understand what inline caches are doing, let's take a look at what happens with a really simple script which accesses the string property on F. If we run it a million times, it's always accessing the string property on F. This is actually optimized away. Again, details, but anyway. So interpreter and baseline interpreter are both mostly using the bytecode to actually run the code. The baseline interpreter creates the inline caches. It's a piece of information that tells us that, for example, the thing that we're operating on is a string, so we can start preparing to have a string, native code associated to a string. And then the inline cache says, is it a string? Do the string stuff. And then Ion compiled, it doesn't quite only look at the inline cache, but if it's a string, it does stuff. So the same concept is being used everywhere. So that allows the compiler to be like, I know what this thing is, I can do this work faster. Right, and Ian has a really great clarification. Ion is built using bytecode, and we use bytecode offsets when we bail out of Ion into other tiers. So that's going to be important when we look at where this when we get to the end of this list of things. Okay, so why do we need all of these steps? So why don't we skip some steps? Do we really need that baseline interpreter? So the problem is polymorphism. There's a really great text from JS Core from the WebKit. I don't know how best to refer to them. JS Core is the JavaScript engine in Safari. They write blog posts on WebKit, on the WebKit blog. So there's a really great one about speculation in JavaScript that you should definitely check out, because that's what we're doing here. We are speculating what the thing is on F, and I made a little mistake here. F should have square brackets instead of rounded brackets. So let's say that for the first 100,000 times, F has a string as the property. The property access, computed property access, is being done with a string. And that happens for the first like 100,000 times. And then suddenly, and again, there's issues with this code, I'm terribly sorry. There should be an else statement here. And then suddenly we switch to a number. Suddenly our assumptions are broken. Suddenly the thing that we thought was going to happen is not going to happen. So our compiler is sad. The world as it knew it is not present. So yeah, it's just going to sit over there and not be happy. But how does this actually work in the code? Well, we have these things called guards. And what guards do is they check if our assumptions are still relevant. And if they are, we can just keep going as we were. And if they aren't, we can do something called a fallback or a bailout. And that bailout will take us back to some previous state in the compilation. Now, what the ICs do is they allow us to have a little bit more information than nothing. So if we bailed out with, if we just said all of our assumptions are wrong, we are bailing out and we're not going to keep any of that information, that would be a bit of a waste of time, because maybe the value that accesses f might be a string again someday. So what we can do is we can actually go straight into the baseline interpreter. Instead of going all the way back to the interpreter, we can go back to the baseline interpreter, which is a bit faster, and we can add something to our assumptions, which is, oh, it's not a string, but it is a number. And then we can start counting and seeing like, okay, how many numbers are we getting? And then we can build specialized code, native code, to do the thing that numbers need to do. So that's basically the overall idea of what we're going to do here today. Again, the two people have posted the WebKit post. It's a fantastic write-up. It also goes deep into how JavaScript core implements it, which is different from how we implement it. And the overview on speculation is a really great introduction to how this all works. They also have a great section on related work. I recommend reading that as well. Okay. Any questions so far while I get ready to start programming? Also, someone asks if Chakra.js is still relevant. I think they're still updating it, but I don't think it's going to be kept around for very long. So, yeah. Okay, people are saying let's code, so let's code. Where to start? Well, let's take a look at what we already did. Let's start in the interpreter. Is it in the VM? Do I remember where anything is? Yes, it is in the VM. What did I do? Am I in the right folder to begin with? No. Okay. I don't need that. Okay. So let's look at the interpreter and what we originally did in the interpreter and just remind ourselves of what we were doing. Oh, I am working on a new version of this. That's where I should be. We can't have everything revealed to us before we do it ourselves. So I'm going back in time. I have a silly question. What does MFW stand for? Okay. Oh, okay, good. I see. I'm behind the times. Okay, cool. Now we're where we should be. So we have this, so what is an interpreter? It's a giant for loop that looks at all of the bytecode and then does stuff according to the bytecode. And what we have here is the original bytecode that we wrote way back when, like ages ago. And we need to make a slight change to it. Because, and I'll show you in the baseline, I just need to find where. Oh, that's funny. I believe it's code generator. Okay. Okay, cool. So someone's asking, they've been following the stream for a while and they tried to build SpiderMonkey themselves and did mach run and it launches the browser. While I'm doing this, can you answer, did you change mach run to choose the application type to be the JS? Because depending on what you have in your inside of your MOS config, it'll run a different application. I run mine kind of old school, which is you can do bin config and then do dist. Well, I can show you what I do. Don't do this. Don't do what I do. Be different. Be more modern. I do this. Now you'll notice that this is a really long thing. You have to specify which SDK you have if you're on macOS. I also have Ccache enabled, and two things you probably want is to enable debug and disable optimize. And then I manually run the configure script. You don't actually want to do this. But then you can also just do dist bin.js and then do JavaScript in there. So that's how I do it. Don't do this. This is a bad idea. Okay, cool. Okay, so prepareSetElem. So one of the problems we can see with our old implementation is that we are calling into the VM. So our previous implementation entirely works by skipping all of the optimizations that are possible. It skips doing anything that has to do with actually how the gist should work. Instead, what we do is what is normally a fallback. What we do here is we call the VM, and you can see that in this line here. So we're calling the VM here, and we're calling the VM here. And we don't want to do this. So we need to make a couple of changes, and we're going to start by making changes in the interpreter. And the interpreter basically does the same thing. We've constructed our prepareSetElem out of the two bytecode that used to exist, that still exist, but we're not using them. Check object coercible and toProperty key. So we just created a bytecode that combines them and we manually smashed them together. And now let's do it properly. So I'm gonna just grab this and delete it. And we are going to go to, I'm gonna dump it here in the same space as what we had before. So I'm going to do prepareSetElem operation. That's how I'm going to name it. And so much work. I wonder if we're going to get through all of this today. I'm not so sure we will, but I will try. And I'm going to go a little bit later than normal. I'm probably going to go for 2 hours today instead of 1. Okay, so we have check val, and then we have another handle value. Handle values are a special way of representing JavaScript values in the engine. And I think those are the two. Is that all we're using here? No, we also have a result. Which is mutable, because the result is the thing that we output. Okay, cool. And I think that this should pretty much be what we want. So now instead of having two things, we have one thing, and then we need to actually use it. prepareSetElem. We do it exactly the same as this one. The main difference being that we also have a check val. Did I somehow lose? No, everything's good. Cool. So we have a pattern here. We're always going to have the object first, followed by the value that's going to be turned into a key. And that's going to be consistent throughout. And if this operation, for whatever reason, fails, we will go to error. Cool. So in order to be able to use this in the jits, we need to add it to the, so we do need to use it in the jits because we're going to have to be able to fall back on this code. So if something goes wrong and the jits don't know what to do, like the example that you saw of like, we only have a string and this should actually be a number, what we'll do is we will go into the fallback path. And for that, we need to export our fallback path, which is prepareSetElem operation. And I have the file that we need to edit right here. And we did this before, we did this last time. Throw object coercible. If I remember correctly, this has to be in alphabetical order. And additionally, we don't want to have this just anywhere. This is going to have to be in a special spot, which is here. But before we define that, let's actually define the thing that we're going to use it in. So before we get here, so far we just do I not have another tab? I do. Okay, good. Let's actually get everything set up so that we can do things properly. And I made a mess here last time. I didn't need that. Right. So we want a. This is the wrong spot. This is another spot. This is already ion. We don't want to be there. There we go. Okay, so we want to do this in what's the word I'm looking for? In baseline. We're starting off in baseline, and we have this long piece of code that defines the prepareSetElem manually. So we go and we load the values ourselves, which we're going to have to do anyway. Then we do branch tests using the macro assembler. Then we bind a label. So imagine goTo statements, and we're binding a label. We're pushing two args. So we prepare for a VM call, which means we're about to jump into the VM using something called a trampoline. Lynn Clark has a great text on trampolines if you want to read more about those. So we prepare the two arguments that we're going to send along. Then we prepare a template function that tells us what's going to be put into it. And then we call the VM with the name of that function. Then we do it again, exact same thing, but to the to property key operation. Now, if we were doing this way, which we're not going to do it this way, we would go prepare set operation here, and for example, get rid of this stuff, and I think also get rid of, is that what we do? I think we would do this. But this doesn't matter because actually what we want to do is we want to delete all of this code, like so. And instead, what we want to do is type if emit next IC, emit next inline cache. So this is what we actually want to do, but we haven't written the IC for this yet. So let's do that. Right. Okay. I'm gonna do it here so that I don't open too many tabs. when I was doing the practice run of this, I had like so many tabs open. Okay, good. Now we don't have a prepareSetElem here. Ah, there's another thing that I need to do before any of this happens, which is JSSRC yam opcodes. One thing you'll notice is we've got these funny little things at the end, which is JOF byte and JOF IC. JOF IC will tell the engine that we have an IC that we expect here. Okay, so now prepareSetElem is flagged as having an inline cache that goes along with it, just the same as toPropertyKey did. So there we go. These are macros that do a lot of magic in order to make everything happen. Okay, good. Oops. So we have this toPropertyKey thing, and where are we? We are deep inside of init IC entries. Perfect, exactly where we want to be. So I'm going to add a new one. And we don't have this function yet, but I'm going to type it in anyway. Okay, fine. How about I make it before we do it? And we are going to have to add this as well. So what's this doing? We are creating an IC stub. We're allocating a new IC stub, and then we're adding the IC. And we're not going to take a look at what this code does, but it's definitely interesting. So take a look inside of that function if you're interested. Now what we want to do is create this IC, well, okay, I'm going to name it. And this kind is going to be there in a second. Good. Okay, so the first thing that I should do is I should add the kind. Here we have toPropertyKey fallback. I'm just going to keep it close to toPropertyKey fallback because that's what we're sort of mimicking. And instead of being toPropertyKey fallback, it will be and also here. This is the fallback kind list. Okay. And now we have these pieces, but what we're missing is the actual IC thing. Okay, and where am I right now? So what we want to do is we want to define something that is this prepareSetElem IC. Here we have a list of definitions. I'm basically just going to do the same. And we are doing something very, very similar to property key. The main difference between this and toPropertyKey is that we take 2 arguments instead of 1. toPropertyKey takes a value, and we are taking an object and a value. Oops. This is the kind that we just defined. Okay, that looks good. And here we are in the fallback. So sorry, I'm jumping around a lot. Okay, so we have this function and we basically want to do the same thing. Again, main difference is instead of having one value, which just has one value, we are going to have two values. So I'm going to grab all of this. Okay. And instead of taking one handle value, I'm going to add a second one. We have some information that's being added to this if we want to spew, but I want to change that to our new one. Same deal here. And, okay, so here's the key point. Remember how I just added this fancy new thing called prepareSetElem operation? And you'll notice also right here we have toProperty key in the interpreter. So right now we're in the interpreter, we're running C++ code, we haven't compiled anything natively, and we're calling this function called toProperty key operation. And I just added a single function called prepareSetElem operation. And that is exactly what we want to use here. Except because that's our fallback. That's what we're falling back on. Again, same stuff as always. Let me double check. I think I am missing, okay. This first value should be an object. Yes, I also need to change the this. Oh yes, I actually totally got burnt by this while I was doing this in preparation. Thank you, Ian. That was really painful the last time I did it. Okay, so we have that, and we have an object here, and we have a value here. So it's really great that we have this code already available, that we just need to sort of map our understanding of the thing that we're trying to add to something that exists before. It's great. It's like mob programming. I get Ian to like coach me through this. This is awesome. Okay, good. Okay, awesome. But we're again at the point where we have more things that are undefined, specifically this prepareSetElem IR generator. What the heck is that? But that's the main thing that we don't have implemented here. And also we have this IC prepareSetElem. I think I just defined that. Yes. And additionally, I think I need to add this to the header file. Here we go. I'll put it at the top. Make it pretty. That looks right. Okay, good. Okay, so everything is defined except for prepareSetElem IR generator. Oops, now it's even gone. Yay. And I think where I want to implement that is in, is it here? No, this isn't here. Let me look at my notes, because I'm not doing searches. Cache error. Yeah, thank you, Ian. Good. It's in here. Perfect. Ian works on the jits, unlike me. Well, I guess I'm working on them now. And okay, so toProperty key is defined in a couple of spots here. For example, here's the thing that we are missing. And let's read it before we implement it, because that's going to be really useful. So we have a definition here for toProperty key IR generator. Again, takes a bunch of stuff. But where it gets interesting is when we do this try attach stub bit. And I think we even see that here. Try attach stub, but now we need to do it for this thing. So what this does, and you will, if you recall the little comic that I showed you earlier, it's actually trying to attach stubs for different types. And inside of each one of these attach functions, we're doing a check, like, is it an int32? And if it's not an int32, we don't attach. We don't attach this stub to this piece of IR, to this inline cache, I guess? What words do I use here? What are the best words to describe this? I'm not sure. I haven't said this out loud yet. Then we take the value, the val operand ID, and we also guard for int32. And there is a YAML file, which I'll pull up, which defines all of this stuff. Completely forgot the name of this file. Where do we define that? Because it's always interesting to see how things go all the way down, so I want to make sure that I show you that. I can find it by doing .yaml. There we go. Goodness, that was hard to find. Here we are. This has documentation on the cache IR opcodes and how they work. And for example, we can look at guard int, was it int32? Or was it 32? Guard to int32. So we have the information about these written out in this file, and the documentation about how these works is here. Good. So this is an example of int32. We also try to attach number and do specific steps for that. String, symbol, etc. Well, actually, I think those are all of them. And what we're going to do is we're doing the exact same thing. The only difference between this code and what we want to do is that additional operation, is that additional value that English is the additional object, which might be null, that we want to guard against. If it's null, then we don't want to attach stuff like that. Okay. Oh. That's what I get for overloading my J's. Okay, good. And we also have an extra value here, which is going to be object. And then now this is going to be a lot of rewriting. How can I do this faster? Can I spell also? Yes, it looks like I can. Okay, everything's renamed, and we're not reusing the code from before because we need to do something different. And again, just to make sure everything's updated. Yeah, I'm gonna leave that comment as it is because we're effectively doing a two-property key here. And then the thing that I forgot that Yandem reminded me of is that I needed to have both things here. What did I want to do here? Well, actually, I think that this, I can't remember now. This just needs to be 1 because the thing that we're passing here is 1. And the other thing that I did with this was, oh, I think I know why I messed up earlier. I think I know why I messed up earlier because I didn't guard, in my previous implementation of this, I didn't guard to make sure that the object wasn't undefined. I only checked here if the value was undefined, and that's not right. But let's start with that and then we'll fix it later. Because we can always fix it. I think that's what it's called. Is null or undefined? Yes. Because, so probably you see the mistake that I'm making, which is I'm only checking when we attach, but we also have to check when we run the code. And I'm not doing that right now, and we'll fix it later. Good. We might go into a little bit of exploratory stuff. I don't want to deviate from what I initially planned because when I compile the code, I want to make sure that it works. So this will be wrong, but we'll fix it later. And then if there's time, we'll fix it in this stream. If there's not time, then I'll cover it in a future stream. Okay, cool. So incorrect code, but code nonetheless. And I think that might be everything for baseline. No, it's not. It's probably not. Oh, thank you very much, Ian. You're totally right. It shouldn't be and, it should be or. I'm in the wrong place. I also missed one. Did I only miss one? I did only miss one. How did I do that even? Good question. Why is it not no negation? Yes, you're right. Good question. You're totally right. And EvilPie is also right. I could just do this and try attach. What can you do? I will make it better later. No, I'm going to make it better now. Let's undo everything that I just did. Then we can do mob programming. And I can learn from you, which is going to be really exciting for me. Because I already learned a lot from the questions that people ask. So I guess we can just basically do this. I think this or is capitalized, and this shouldn't be like that. Good. EvilPie, does that look all right? Actually, maybe this is important. No, sorry. Okay. All right, I'm gonna stick to what I did originally, and then we can. I'm gonna stick to what I did originally, and then we can improve on it in future iterations. I'm totally not going to have time to do the ion for this, am I? It's going to have to be the next episode. Okay, so it's incorrect, but it's there, and theoretically it's there was something else that I needed to do, I think. No, I think that's it for this part of the story. Unless I didn't do the stuff in the VM. Okay. Did I do the stuff in the VM? No, I didn't. Okay, so why do we need to add something new to the VM? And why do we need to add it where we need to do it? So the issue is here, and I think I just accidentally closed a bunch of files. Tail call VM function list. This is a special list. It's not the same as the function list we added to last time. And here, ooh. There's a place where I specifically added this. Okay. This is it. So this is wrong. What I initially did here is wrong. I need to do a tail call to the VM. Oh, no. Do prepareSetElem fallback, I think, is the thing that needs to happen. And we need to do the same things here. prepareSetElem. Okay. Wait, this is wrong. This is all wrong. What am I doing? This was right. I got confused and wrote the wrong thing. So we're in do prepareSetElem. The problem is here we're in image to property key, which shouldn't be to property key. It should be prepareSetElem. And we need to make changes here as well, because we have two values and it's the second value, second register. So we're always doing it object then ID, and the ID is the thing that we overwrite. Actually, I'm not too sure if that needs to be changed, but it worked when I ran it. Handle value, and then instead of do to property key here, we need to do prepareSetElem operation. No, wrong again. Value, da-da-da. Okay, and now we need to add stuff to the tail call VM. And this has to be alphabetical. And I'm missing fallback. Okay, so that's right now. And I'm still missing something here because I haven't exported prepareSetElem here, I think. I haven't. And I need to. I'm sure that I need to. need to? Yes, I do need to. Okay, good. And this should actually get us to the point where we have baseline ICs working. Okay. So the thing we need to think about now is I actually have it implemented through Ion and also our new JIT, which is Warp. Well, Warp. The new JIT is called Warp. Do you want me to keep going, or do you want me to stop and we can chat? I can go either way. I can also build this and see if it works. Okay, so one person says keep going, so I keep going into Ion, and then maybe we even get all the way into Warp, and then we finish this. So exciting. And I'm doing it wrong because I don't spend that much time in the JITs, but this is an exciting experience for me as well. Okay, next. So one of the questions that I had when I was thinking about like doing all of this is, what's the real difference between Ion and baseline? And the answer that I came to is that like baseline isn't aware of registers, and Ion is aware of specific registers. Okay, I have some errors. Oh, fantastic. We can fix errors first. So as far as I understand, that's the fundamental difference between the two JITs, as well as like optimizations that happen. And the work through the registers is going to be what's distinct between these two JITs. Okay. You can stop and I'll do it not concurrently. Tell me why you're sad. I forgot to define something, I'm sure of it. I thought I got everything, but I probably missed something. Yeah, so Iona mentions that it's like how I think through things. I think it's also really interesting to watch people work because you can see how they think through stuff. I often learn a lot about how people think. This is a little bit artificial because I've already done the task once. This is my second time doing it. And I just have a series of notes about what I need to remember when I do it, like stuff that were easy to mix up when I was doing it the first time. And I actually had an initial review of this patch. It's not a full review. It's a review just for the stream to make sure that I didn't get anything grotesquely wrong. And it's not horribly wrong. It's just sort of wrong. So there'll still be a little bit of fixing and stuff, and this is really taking a long time. Okay. Then I guess while it's figuring itself out, maybe I can figure out why I was complaining. And how will I do that? I'll do that by looking at the div. Someone is asking about advertising projects on this channel. That's not something I'll be doing, so. Okay, so I forgot to define something. Let's see where I forgot that. Okay, here's a change. So we got to delete lots of stuff from baseline code gen because we're going to rely on the ICs from now on. I added IC prepareSetElem fallback to baseline IC. And did I update the header file for that? I updated it, yes. IC stands for inline cache. Then there's cache IR. Did I update cache IR header file? I did not. Excellent. Maybe I even have it open here. And the thing that I need to do is get not toProperty key, but this one. Oh, I have a few things that I need to add. Okay, good. I messed up. This is awesome. Wait. What? Yes, correct. I made a mistake. This is good. We found it. Oh, I knew that I was missing something because I was wondering when I was going to do this part of the code. And then we have the attached decisions. And then we need to update this too. How long is the stream? That's a great question. I was planning on having it at an hour and we're half an hour over, so. Yeah, so if hopefully I'm going to finish all the way up to Ion today, and then yeah, ideally I would have gotten all the way to Warp, but maybe we won't get there. But yeah, I'm not sure we're going to get all the way to Ion, to be honest. Okay, I think that was the problem. And no, there's another problem. prepareSetElem operation expanded macro. No member name prepareSetElem operation in namespace.js. Fascinating. That's very interesting. I could swear they're... Ooh. Oh, they're right. Yep. I'm just going to add it to the bottom of this. What should this look like? Actually, I'm just going to hang it like this. Anything looking amiss? No, that looks right. Okay, and I need to replace the go-tos. Yeah, thank you very much. Fantastic. There's a question of if this will be committed to Mozilla Central. I initially thought that this would be purely educational, but it might, which is very exciting. So this might actually go into Mozilla Central. Okay, it should not complain anymore. So this is going to take forever, and hopefully it doesn't die, but it might. And while it's doing its thing, I will get started on the next step, which is going to be Ion. So I did a little bit of a preamble about what is Ion. So Ion is our optimizing compiler, and baseline JIT is technically not an optimizing compiler. The two are distinguished by what techniques they use in order to do optimization. It doesn't mean that baseline doesn't do optimizations. It just means that the thing that is called an optimized compiler doesn't necessarily fit for baseline. There's a lot of optimizations you can do before you start doing what are considered conventional optimizations, and that's what baseline does. But now we're going to do ion. Yes, those are the right notes. Is cache IR and IC the same thing? Not quite. So the ICs are inline caches, and cache IR is like the language that gets used. The ICs are, yeah, okay, so Nicola has a good description of it. It's a way to decompose inline caches. But wait, how can I put it better? Yeah, so the inline caches are the actual things that are associated to scripts, and cache IR is the language that we use to generate that that stub, I guess is the best word I can use for it, that piece. So yeah, inline caches, you can think of it as this is the thing that gets actually inserted, and cache IR is the language around that. Oh yeah, and I also forgot one other thing in baseline, so this might still fail. Oh good, it's failing. Because I forgot a comma, as you do. Wait, did I? Is that why it's failing? Yes, 2928. Coding live. This is the thrill. Okay, good. Now it's going to freak out because I did too much stuff. Good, okay. There was one last piece that I forgot, which is no, this is in the jits. It is here. Okay, and I looked at this earlier, but I didn't do anything with it because I got distracted by something else. But what we have to do here is add a little bit of information about how prepareSetElem works. So what we do here is we say that we've got two inputs and we're saying where they are. So R0 and R1. So the first thing, which is the object, we're always starting with object and then we're going to value. Object is going to be living in R0 and then the value is going to be living in R1, just to help us keep in mind where we are. Did I forget anything else? Yes, I did. Here. Same thing here. We need to tell the number of inputs for this specific cache kind. Good. I think that covers it. I'm a little bit nervous about going into ion right now because there's a lot to cover and I'm not going to be able to do it in 15 minutes. So what I would propose instead is, how about we fix the mistake that I made? What do people think about that? This is going to be interesting for me as well, because I definitely made a mistake when I was writing the cache IR stuff. Okay. So cache kind instance of, it's not the cache itself. It's a flag to tell us that this is the cache kind. It's an enum that tells us that this is that thing. And let's see if we can run that again. Okay, so I think that there's a mistake here, and so there's two. I think there's two mistakes here. One is that this is really unnecessary, as pointed out by Tom, by Evil Pies. But I'm not fully comfortable with working with this yet. So when I look at these try attach things, it looks like we're attaching stubs. So I guess like if I do try attach here, so what I'm expecting here is we have a stub for int 32 and, you know, yada yada with the rest of them. And Tom, Evil Pies suggested to do try and like, let's say try attach so I'm just going to name it that for now. Yes, Ian is saying I'm not doing anything with the operand 0, and that's right. That is a problem. That's the issue that I want to solve. So there's two things that can be improved here. The first one is to add a try attach here, but this will be a stub just to check if we have object coercible. So if the object is there, we would be checking here. But there's another problem in this code, which is specifically here. I'm only checking when I'm attaching the stub. I'm not doing a guard about when the code itself runs. So the code can run and could potentially run into problems if that value changes and it's no longer an object. At least this is how I'm modeling it in my head. So we have this. So we need to do something with this. And I wonder if we have guard to object, and I can check that by looking at the cache list, which Ian's was very helpful and had earlier. And I can never remember the name of, but I should have it in my history. There it is. So maybe we have something in here that I can use. Guard to object. That actually sounds pretty useful. I think I can use just guard to object. Can I? Unless it could potentially be a string, but I don't think so. How does guard to object work? This is me doing this without being able to actually run the code. So when I program, I usually program rather exploratory in an exploratory fashion, because I like seeing what happens, and I'm less of an attentive reader, so I tend to try things out. But during the stream, my compile times are really long, so I can't rely on it. So I have to pick up better habits, because otherwise I would just try it and see if it worked. We also have guard is null or undefined. Okay, let's see what how this is used. Guard to object. This guard is actually overly tight, so we are in try attach string object concat. And yeah, we don't have guard is not null or undefined. I wonder if object would be enough. But in the code, sorry, not in the code, in the specification, let's go back to the spec and read the spec. Because in the specification, it tells us why it's probably a problem for me to use guard to object. If we take a look at require to coercible, it should return the argument for all of these cases. So Boolean, number, string, symbol, big int, and object. They should all be valid. And then only if it's null or undefined, we shouldn't we should throw a type error exception. Yeah, the reason my compile times are slow is because I'm both streaming, I'm working off a laptop and I'm both streaming on it and compiling on it. So it's just having a very hard time with this. So let's take another look. So we probably can't do guard to object. But maybe, I don't know. Right, let's take another look at guard to object. Guard to object is fine for now. It's not going to be fully right, but because what I can do is something like this. We can check if it's an object and then do these. And then same thing for Boolean and all of the, oh, I'm not showing my screen. Sorry. I got distracted. What I'm looking at is other uses of guard to object. Yeah, I can add guard in not null or undefined in the next stream, and then we can just keep going with baseline. Okay, so for now, let's do guard to object. Wait, how do you use this? Okay. This is also wrong. Did we build? No, didn't build. Okay, so also getting down to the last 10 minutes. Whew. So this is going to be the, tell me folks, am I doing the right thing? Ian and Evil Pies? Is this sort of the direction I should be going in? Since I can't test. Ah, yes, you're right. Also, I probably shouldn't be using the same thing over again. And I feel like I should be using this object ID somewhere. Okay, let's see how it's being used. Try attach native. To object. Okay, cool. All right, so I'm just gonna dump all of the stuff. We will deal with this later. Once we come back in a couple of days. So we won't use this value yet. Yeah, let's do this. Got too many spaces. And that looks right. Okay, this was complaining for some reason. Let's find out why. It's very unhappy. Error. No. Remember prepareSetElem in cache kind jit. Okay. I forgot to define that somewhere. Yeah, I can actually return the ignore the return value from that. Correct. Oh, I don't need that value at all. How about I just grab this? Good. And the problem is, oh, the same as before. I haven't defined something. I probably haven't defined the cache kind somewhere important. Look in, okay, thank you. Oh. Around line 166. Oh, yes, I even looked at this. Okay, yeah, good. Okay. Ideally, this will work now. Okay, so we've got 5 minutes left until the hour, and this stream has been 1 hour longer than I expected because I'm always planning for too much content. So next stream, which will be in 2 weeks, we are going to properly fix the thing that I did wrong in the baseline, in the cache IR code. And we will continue on with Ion. I don't think that adding a new guard will be a lot of work, so I think we can probably go straight into Ion and continue implementing this feature in Ion. Right now it's not implemented there. It's implemented in a really non-robust way that would never be able to land in tree. So yeah, while we watch this beautiful spew of everything, because I don't do silent, because I didn't do silent in this case, do people have questions? Anything they want to talk about? We talked a little bit about jobs. Maybe people have other questions along those lines. Maybe people have questions about what we did today, or I didn't clarify some things. I'd be very happy to clear up anything. Did I do that again? Come on. How long have I been working on the compiler? I have been on the compiler team for 7 months. And I decided to start streaming about it because I have great ideas of how to not be stressed at work. Yeah, I've been doing it for 7 months. I didn't actually write any C++ before this point. So if you see me doing some really weird stuff in C++, it's because I have no idea what I'm doing. And you can definitely tell me that I'm doing something wrong. 3481. Yes. Copy pasting is a bad idea. Why does VM function list have to be alphabetically ordered? I have absolutely no idea. I am also wondering why it has to be alphabetically ordered. Maybe Ian knows. Yeah, I also, okay, so NBP says there probably aren't any specific reasons other than diffing. I also suspected something along these lines because it didn't seem like it had to be there. Good. It's complaining again. Undeclared identifier. I'm going to make this run before I sign off. Because I named it different things. I'm so good at this. Look at how great I am at programming. I should be more consistent with my naming. Okay, that should be right now. And it's complaining about something else, which is in baseline 753. Oh, let's try to build it again. One question I have is, are the drawings useful? Because they take a lot of time. Do people like the drawings? Should I keep doing them? They're really ugly because I never have enough time for them. I spent like an entire day on them today. And I was like, oh god, they don't look very good, but they take so much time. So I don't know if people want to keep getting those. Okay, yes. Okay, yes. I will keep doing the drawings. No matching member for tail call. I did something else wrong. Probably that's in here. Interesting. Is that because I did this wrong? They are published somewhere. They're published on my website, which I also do very little care on, which I should really do some more. No matching constructor for the initializer to property key IR generator. That's odd. Why do I have that? Oh, that's why. Good. Now it'll work. Yeah, I should lint the code in the drawings. I should actually write them. I'm always doing it sort of loosely, and I should just write them out first and then write them up. Everybody excited for Friday? Okay, I have a couple of errors again. There's still no matching member function call to tail call VM. Why is it thinking that? Oh, interesting. There is a reason for the ordering, kind of, which is that there's a small amount of semantics associated to ordering in our GC enum. Okay, I'll fix these first. Oh. Did I accidentally change this when I shouldn't have? I did accidentally change that when I shouldn't have. Good. Hopefully this is the last time that I'm doing this. Why might this not work? Found it. Ooh, these are hard to catch. Okay, this should be the last time. Yes, we do have a different list for VM function and tail call VM function, but that wasn't the issue here. The problem that the mistake that I made actually was because I copy pasted and didn't write all the code out by hand, I had a mistake here, which is one of the values in the template was still toProperty key. So it didn't recognize what I was trying to get. And it said that there was no definition for this function when there was one. I just had misspecified it. I think this is going to work. I'm excited. The compilation error on the function type, was it the ordering that you argued for? Oh, I want to see that. You can look with me. Oops, that's the wrong thing. That's also the wrong thing. I'm very disappointed with my drawing situation because it totally didn't work this time. Let's see. What did this do? Oh no, there's so much conversation. Okay, eliminate hundreds of static constructors. Use const expression for VM function data. This was not possible with the linked list, but with the new design stores all data in the const array. Make it easier to define a new VM function. I am very thankful for that. Duplicate VM function copies in baseline, ion, and ICs. Get rid of the read-only hash map or VM function code lookup. We can use a vector instead. Oh, I have good news for everybody. It worked. Let's see it work. Yay. So now we can say row equals null. And we can say key equals a nasty and then we can go key. Oh, wait, I need to actually do this in baseline. Can I do just baseline here? This is not the moment of truth yet. It works because it's supposed to work. And now, will it complain? Yes, it works. It works exactly as it's supposed to. Hooray. We're done. Okay, that was a much longer stream than I expected. Thank you all for sticking around and watching this incredible journey that we've all been on together. Now we can take a break. It's going to be another 2 weeks until the next one because it's easier for me to prepare properly. Although clearly I over-prepared for this stream because I have like at least another full day of streaming ahead. But I'm definitely going to be sticking to at least the 2 week schedule. We might actually end up going to a monthly schedule depending on how my other work goes. Sorry about all the hiccups, the technical difficulties and things. I'll try to make sure that those are sorted out for the next time that we stream. I hope you enjoyed it. If you have questions, please feel free to ask them. I'll stick around in the chat for a little while. And you can also ask them in other places, because I have a special repository for everybody, which is in compiler dev. We have a special repository that you can go to, and you can try implementing them yourself. I need to update this to make it more up to date, but for example, you can go and investigate the bug that we're currently working on, and it has some instructions about how to run it, along with the patches that were used. I'm going to update these patches to a cleaned up set of patches, and also how to build SpiderMonkey, which test262 project we're working on. Incidentally, the world is on fire, and people are being killed in the US because of their skin color, and it sucks. Donate if you can. But this is the test that started this whole journey. And yeah, you can check out the stream. It's recorded. You can find all of the stream information here. Definitely check those out if you want to catch up and see me try to figure out what I'm doing in other parts of the codebase. And next week, we're going to be coming back with Ion and a new cache IR, I don't know what to call it, thing, a new cache IR operation.